Now we've completed the process of identifying stream channels from the digital elevation model. What we want to do next is identify the watershed, or the area that drains to a particular location. In this case, we'll use this inlet to this pond. We want to know all the land area that if we drop water here, will it flow into the stream and then into this pond, or will it flow to some other location by some other means? And here we have the air photo, so we can follow along and see how well our stream channel identification is doing. It looks pretty good to me. But for a location like this, if we drop water here, is it going to flow into this channel, or is it going to flow into this channel? So that's what we're going to find out with our watershed analysis tool. So our first step is to create a drain point or a pour point, which is to start out with just going to be a point feature layer. So we're going to go into our geodatabase. We're going to set this as default for now. So right click, new, feature class. It's going to be a point feature, and it's going to be called drain point. We're going to give this the NAD 1983 UTM Zone 19 North coordinate system. And now with that created, right click, edit features, start editing. Select drain point. We want to create a point. We're going to zoom in as far as we can to make sure we're pretty accurate. And we're going to drop a point right near where this stream enters the lake. So now what this program is going to do is search for all those areas that drain to this individual point. So we're going to stop editing, save the edits, and our next step is called snap pour point. So search for tools, and what that does is creates a single raster pixel that is going to take the place of this point, and it's going to use the flow accumulation layer to say, where exactly do I want to place this point to make sure that I'm actually in this stream channel. So snap pour point. So we're going to enter our drain point as the location where we want to have our water draining to. The accumulation raster that we created earlier, and that is going to be the flow accumulation, flow 1. So that's this one here. And that's going to our stream geodatabase. Just hit OK. And now it's using that flow accumulation raster to make sure that this point is actually centered in the channel. Because if it was off-center from the channel, it would not be able to accurately assess the drainage. So let's see if that's moved very much. Zoom right in. And no, it's selected the cell that's right under our point. And the reason that works is that this stream channel was identified from the same flow accumulation raster that this point is searching for. If you had an old streams layer like the from the old topographic maps or from a 10-meter digital elevation model from the topo lines, you might see this pixel move over here or over here. But since this is all from the same data set, it makes sense that we have this raster pixel falling right where this point was placed. So our final step here is very creatively called Watershed. In Spatial Analyst, and it wants the flow direction. That's the flow direct fill 1. We want the pour point that we just snapped, and that's the snap pour drain 1. And that is again going to our geodatabase. So now that has created a raster layer showing all the pixels that drain to this individual point. Let's zoom to that layer. We can see that all of this land area, and this is where our elevation model was cut off, so it should follow along this ridge line as well. But all of these areas will drain into this stream and eventually this point. So let's change this from a raster to a vector. Search for tools, raster to polygon. I'm going to use Watershed Flow 1. Send that to our geodatabase. OK. Now we can turn the raster off, the polygon on. We can make that a hollow polygon, and we'll set that to a thick yellow. That yellow lines show up well on air photos. So now we see, with the exception of this cutoff of the data, the exact locations where if you poured a glass of water here, that water would end up first in this lake and then through this stream and to this point that drains into this lake.